Hi friends, in this video we will talk about the CAP theorem. CAP theorem is the most important concept in the system design. Indirectly we need to say that it is a fundamental concept for the system design. Okay, why the CAP theorem is the most important for the system design, and what the CAP theorem will says generally, and how it will be proved. Okay, with examples we will discuss everything in detail. It is really very important, friends. Don't skip this video. Okay, it's really important for the system design. It is a most fundamental block for the system design. Okay, let's start. CAP theorem. In the CAP theorem, C indicates consistency. A indicates availability. P indicates partition tolerance. Okay, before we will discuss about the CAP theorem, we need to understand about this CAP principle. That means C means consistency, A means availability, and P means partition tolerance. Let's understand these terms very clearly. We need to understand these terms very clearly, then only we can clearly understand what the CAP theorem will says. Okay, first we will discuss about consistency. What is meant by the consistency? Consistency means every read should receive recent write. Okay, it shows that your application had the consistency. Let's understand in detail with example. Let us consider one application, one banking application. Okay, banking application. Consider one user A. Initially, user A deposits the money. That means performs a write operation. He deposits 1000 rupees money. Okay, when the user A immediately performs a read operation, to check the balance, it should shows 1000 rupees. Okay, that means every read should receives the recent write. Okay, whenever the user A performs a write operation, that means deposit the money 1000 rupees, when the user checks the balance immediately right after that, it should shows 1000. Okay, that means your read should have the recent write, should receive the recent write. That means your application denotes that it has the consistency. Okay, clear? That means the recent write information should receives when the user performs a read request, then your application would be have the consistent behavior. Now let's discuss about availability behavior. Availability. What is meant by the availability? Availability means every request should receives should receive response. Okay, response, and that response should be non-error. Should be non-error response. That means your application had the availability. Let's discuss in detail. For example, you had the application, okay, if user performs any kind of an operation, whether it will be the read operation or write operation, it should gives the response. Whether it will be the write operation, whether read operation, it should gives a response without an error. Okay, if the application request would receive error response, that means your application is not available. Okay, your application should gives a response. Should gives a error response, it is also the fine, but error response means it should be the user error response. It will be fine. But if application receives an error response without an user specifying errors, then your application should not have availability behavior. That means one of the component is let it down. Okay, this is what availability behavior will states. Let's discuss about partition tolerance. Partition tolerance. We need to understand this property very clearly. It is really important. Okay, for example, you build an application. You build an application. Okay, initially the capacity is, it consists of CPU, 8 core CPU, RAM 16 GB RAM. Okay, what happened if you maintain your application with single instance with capacity of CPU 8 core and RAM with 16 GB? If you're maintaining the single instance application in the production, will it scales? No, it wouldn't scales. For example, if you maintain the single instance, if number of requests are increases, what happened? It will be leads to application down. Okay, we need to increase the CPU, we need to increase the RAM, or we need to increase the replicas. Okay, generally we doesn't prefer the vertical scaling, we prefer the horizontal scaling. That means what we have to do in the next step, we are increase the application replicas. That means replica 1, replica 2, replica 3. Okay, we increased our application to 3 replicas. Okay, 3 replicas. Now what happened if the number of requests will be increases? It will be distributed. If again number of requests will increases in future, we will make an horizontal scaling. Okay, now it is fine. Okay, your application is going to scale, any number of requests will come. Now the challenge is, what happened if all the replicas will place in single network. Okay, what happened if all the replicas will place in single network, which is absolutely we are doing the wrong, because if your network is goes down, entire replicas is going to be down. Okay, what happened if the network is goes down? If the network is goes down, entire replicas are down. Okay, so generally in the distributed systems we should maintain the two networks. Okay, you should maintain the two networks or more than two networks, and we will distribute it our replicas in a different networks. Okay, now what happened? We are maintaining two networks. In the network 1, these two replicas are placed, and another replica is placed in the network 2. Now what happened if any of the network will goes down? Our application is still survive. Okay, now what if your application replicas are maintained into different networks? If any of network goes down, your application is still survive. Still survive. Okay, right? If your application is placed into different networks, if any network goes down, still your application is able to survive. This property is nothing but an partition tolerance. Partition tolerance. If your application had that behavior, then it shows that your application is partition tolerance. Okay, these are the three terms in the CAP theorem. The first one is a consistency, and second one is a availability, and third one is a partition tolerance. In simple words, let's recap these three parameters. The first one is a consistency. Consistency means every read should receives the recent write data. If your application had that behavior, then your application had the consistent behavior. What is meant by the availability? Availability means every request should receive the proper response. It should not be an error response. Okay, even user defined error messages is also fine. Okay, user defined error message is also fine. That means your application is working. If your request abruptly receives an error messages, that means it shows that one of the component is not available. Okay, if the every request should receive a response proper way, then it shows that your application had the availability behavior. What is meant by the partition tolerance? Your application is still able to respond even there are a network failures, then your application had a partition tolerance behavior. Okay, this is what CAP denotes. Now what the CAP theorem will says now. Let's discuss what the CAP theorem will says. CAP theorem. Okay, we will take the three circles. First circle indicates consistency, second circle indicates availability, third circle indicates partition tolerance. Okay, these three properties. The combination of C and A denotes CA system. Right? Combination of C and P denotes CP system. Combination of P and A denotes AP system. Okay. Combination of C and A and P denotes CAP system. Now what the CAP theorem will says means your application will able to exhibit either one of the two properties, not all the three properties. Okay, what the CAP theorem says, your application will able to exhibit only two properties at once, not all the three properties. Three properties at once. Okay, what the CAP theorem denotes, every application, whether it will be the CA system, whether it will be a CP system, whether it will be a AP system, but not CAP system. Okay, this will not exist at all. This is what the CAP theorem will says. At once, it only exhibits two properties. That means whether it will be a CA system, whether it will be the CP system or AP system, but not the three. This is what the CAP theorem will denotes. Let's discuss in detail what is meant by the CA system, what is meant by the CP system, what is meant by the AP system. Okay. According to the CAP theorem, we have whether CP systems, second one is AP system, third one is CA system. Okay. In these three systems, generally in the production, there is no CA system. CA systems is generally used for standalone purposes, standalone or testing purposes. Okay, why? Already we discussed the reason. Okay, if your application had a single instance, it would not scale if the number of requests is increases. Okay, single instance will not work if number of requests are increases. Right? Single instances will not work. That means if to scale the number of requests, we should make whether vertical scaling or horizontal scaling. Okay, vertical scaling, it's not so that much easy. Generally we will prefer an horizontal scaling. That means we have the replicas. If all the replicas placed in single network, if network goes down, what happened? All replicas are going to be down. All replicas are down, right? So that means we generally placed our replicas in two different networks. Two different networks. That means if one of the network goes down, still our application will works. Our application will work. That means by default we have partition tolerance. That means when we have the partition tolerance according to the CAP theorem, whether we have the CP system in the production, whether we have AP system in the production, okay, according to the CAP theorem, whether there will be a CP system in the production, whether there is a AP system in the production. Okay, generally CS systems are not used in the production. Where we used the CP systems, where we used the AP systems, let's discuss the examples. Okay, first one, CP system. Okay, CP systems. CP system what? CP system priority is consistency and partition tolerance. Partition tolerance and less priority to the availability. Okay, simple example for the CP system is, generally usage is payment systems. Payment systems should maintain the consistency behavior than availability. Okay, let's take the banking application. If the user deposits the money, money like 10,000 rupees, when he inquire for the balance, it should shows the 1,000. Okay, it should give priority to the consistency. Even application will fails. For example, if user inquires a balance, still we are getting the application as a fail. It's okay and fine. It is not that much impact than showing the wrong balance, right? So that's why in the payment systems, the consistency and partition tolerance has a high priority than the availability. Okay, than the availability. If you consider AP systems, let us consider an AP system. In the AP systems, what is the priority? Availability and partition tolerance. In this case, there is less priority to the consistency. Consistency is there, but there is a less priority. Okay, less priority to the consistency. That means eventually consistent. Okay. Simple example for the AP systems are product catalog recommendations. Product catalog recommendations. Okay. If you consider the product catalog recommendations, even there is no consistency. For example, for one user it shows a different products, for another user it shows a different products. It is absolutely fine, but it should give the priority to the availability. Partition tolerance is always exist. The product catalog recommendation engine should give the priority to the availability. Even different users for getting the different responses, which is absolutely fine, but getting the response is a high priority in the case of the product recommendations, catalog recommendations. Okay, different users showing different responses is absolutely fine, but showing response is more important. Okay, but in the case of the banking application, if different users are showing the different responses, which is absolutely not fine, right? Different responses means, for example, a user transfers some X money for 10,000 rupees money. Okay, a user should shows a balance, it should be deducted from the exact balance. From one system it is showing the balance is deducted, for one time it is showing balance is not get detected, which is absolutely wrong, right? In the case of the product catalog recommendations, each time different responses are coming for the single user is also absolutely fine, right? For the single user, for each time there is a two different responses are coming from the product catalog recommendations, it is not that much impact. Okay, even for single user, different responses are coming for each time, which is absolutely fine. So that's why AP systems more preferred than the CP systems when compared to the product catalog recommendations. Okay. Let's take the Amazon or e-commerce website. In the Amazon e-commerce website, there are two modules. One is a payment system, one is a product catalog. Okay, for product catalog, we should use AP systems. Consistency is not that much important here. Each time showing the different products, which is absolutely fine. But for the payment, it should be the CP systems. For every time, it should shows same response. Whether payment is done, it should be done. Whether payment is declined, it should be declined. There is no ambiguity. Even the payment server is down, which is absolutely fine, but showing the response is absolutely wrong in the case of payment servers. Okay, in the Amazon e-commerce websites, they are using the AP systems as well as the CP systems, depends upon the functionality. Okay, I hope you can clearly understand what is the CP systems and where it is used, what is the AP systems and where it is used, and what is the CS system. CS system is nothing but on the consistency and availability, and there is no partition tolerance. That means a single instance. Okay, it shows the CS systems. Okay, and the examples of CP systems and AP systems and CA systems as well. Now we need to understand that CAP theorem is correct or not. What the CAP theorem states? The CAP theorem is simply saying that out of the 3 properties in CAP, only 2 properties will satisfied once, and other property is eventually satisfied, or sometimes maybe a chances that it is not available also. Okay, this is what CAP theorem would say. Now we need to understand whether the CAP theorem is correct or not with clear-cut examples. With clear-cut examples. We'll discuss examples. Okay, first example for the CP system is MySQL. MySQL in cluster mode. Okay, MySQL in cluster mode. Let's assume that we have a partition tolerance. That means there are 2 networks. Network 1, network 2. Okay, network 2. Network 2. We will consider 3 node cluster. Okay, that means 2 nodes in partition 1, another node in the partition 2. Okay, that means replica 1, this is replica 2 and replica 3. Let's understand MySQL cluster behavior. Okay, okay, in the case of the 3 node cluster, every server will able to take read requests and write requests. This is how the clustering mode of MySQL will work. But there is an quorum level in the MySQL, strict quorum level. Quorum level is generally n by 2 plus 1. Okay, that means for every read and write requests, there are 3 nodes, 3 by 2 plus 1, which is equal to 1 plus 1. 3 by 2 is 1 in the case of programmatically. 1 plus 1, that is equal to 2. That means every read and write request should satisfy quorum. These are the rules. Okay, every read and write should satisfies quorum level. Okay, so to reduce the ambiguity, always prefer odd number of nodes. Okay, they generally, to reduce the ambiguity of an in the quorum judgment, take the odd number of nodes. So odd number of nodes, it will be very easy. Okay, it's okay to take the even number of nodes, but it is little bit of confusion to calculate the quorum levels. Okay, to get the confusion, it is becomes a complicated. For example, if you take the 4 nodes instead of 3 nodes, 4 plus 2 plus 1, 3 nodes should satisfy out of the 4. Okay, if the 2 nodes will get down, your cluster is goes to be get down. So always prefer odd number of nodes. That means your quorum level is perfect. Okay, let's see. Here there are 3 node cluster. The quorum level is 2. That means to satisfy the write request or read request, 2 nodes should be accept. To show 2 nodes should give an acceptance. This is what the quorum level will say. Okay, this is every server will able to take the read request and also the write request, because we are operating the MySQL in the clustering mode. Okay, now let's see what happened. Okay, we have a 3 nodes. We distributed in 2 different networks, 2 nodes in one network and another node in another network. Let's think if network 1 is down. Let's assume network 1 is down. Network 1 is down. That means simply this entire network is down. Sorry. What happened? All the request will goes to the network 2. Let's see what happened. Requests will go to network 2. How many servers in the network 2? Only one server. Does it satisfy the quorum level? Quorum level not satisfied. Not satisfied. Quorum level not satisfied. Now what happened? Both reads and writes will not work, right? So in this case, what will be happen? Let's assume that network 1 is down. Okay, in the production, all the reads and writes will goes to the network 2. What happened? Only one server is there. Does it satisfy the quorum level? It does not satisfy the quorum level, because to satisfy the quorum level, definitely we need to have 2 servers. That means both reads and writes will not work. What happened if the read request and write request will come to the server? It throws an error response, right? It throws an error response. If requests will come, what happened? It throws an error response. It throws an error response. That means what is compromised here? Availability is compromised. Availability is compromised. Okay. In this case, what will happen? Availability is compromised completely. Write request will not work and read request will not work. After some time, this network is up. After some time, this network is up. This network is up. What happened now? Now both the servers will able to take the requests. Here what will be compromised? Availability is compromised, but there is no compromise in the consistency. There is no compromise in the consistency. Let's assume that server 2 is down. Sorry, network 2 is down. Okay, network 2 is down. What happened? Let's discuss here. Network 2 is down. Okay, first case, requests will go to network 1. 2 servers are present. Okay, now what happened? Quorum level satisfied. Okay, quorum level satisfied. Now both reads and writes works. Okay, both reads and writes will work because we have 2 nodes available. It satisfies quorum levels. Okay, now what happened? We have consistency and availability. Is there in this case? Is there? Now what happened? Let's see. Okay, later after some time, network 2 is up. Okay, network 2 is up. Now what has happened? MySQL starts transfer requests from network 1 to network 2, right? Network 1 is up till now, network 2 is down. After some time network 2 comes into the live. So whatever the request is coming to the network 1, this data is start transferring automatically to the network 2. During the transfer, if request comes to network 2, still there is no problem with consistency, because quorum level is 2. Still there is no problem in the consistency because quorum level is 2. What MySQL do? MySQL checks responses from all the three servers. Majority is 2. Okay, this majority is 2. That response is given back. Okay, that response is given back. Here there is no compromise in the consistency. What is a compromise here? Availability is compromised. Since availability is compromised, this is a CP system. Okay, I hope all people should understand these cases. Okay, why the MySQL cluster mode is the CP system. Let's recap these things. For example, we have a network 1 and network 2. There is a partition tolerance in the production. Okay, we have a 3 replicas, MySQL cluster, 3 node cluster, for example. 2 replicas will be deployed in the network 1. 1 replica is deployed in the network 2. Okay, MySQL had a quorum level, which is a formula that is n by 2 plus 1, that is 3 by 2 plus 1. That means 2 nodes should satisfy for every read request and for write request for successful. 2 nodes must and should be satisfied. Okay, let's assume case 1. Let's assume that network 1 is down. If network 1 is down, what happened? All the request will goes to the network 2. All the network request will goes to the network 2. Read doesn't works and write also doesn't works. Okay, here there is no problem with the consistency. Here there is a compromise in availability because the server start giving the error response. Okay, done. Later, after some time, the network 1 is up. There is no request will be acceptance. There is no data transfer is available here. Okay, even the network 1 is up, there is no issue here. Later, after some times, let's assume that the network 2 is down. What happened? All the requests will comes to the network 1. 2 replicas is already there. Okay, 2 replicas is already there. 2 replicas is already there. Quorum levels are satisfied. Both reads and writes will work. Okay, consistency and availability also there in this case. Then after some time, this network 2 server is up. Okay, after some time, this network 3 server is up. Then what happened? Whatever the request was coming to the network 1 during the down of the network 2, the network 1 should start transferring the data to the network 2. Data transfer happened. During the data transfer, if any request was comes to the network 2, for example, any read request will comes to the network 2, there is no issues with the consistency because the MySQL servers took the response of all the 3 nodes and check in the 2 nodes where the majority of the response is there. 2 nodes, the quorum level is satisfied, that response will given to the user. That means in that case also there is no issue with the consistency. Okay, but this MySQL server, there is a compromise in the availability when the network 2 is down. So sorry, when the network 1 is down, there is a compromise in the availability. So that's why MySQL in the cluster node always termed as a CP system. Okay, CAP theorem, whatever the CAP theorem it states, here availability will not satisfied in one case. So that's why entire cluster will be termed as CP system. Okay, where the CP systems are generally used in the payment services, which we discussed already. Okay, this is how the CP system will work. Let's discuss about AP system. That means availability and partition tolerance. Compromise in the consistency. Compromise in consistency. Compromise in the consistency. What is the AP system? Example is Cassandra. Okay, Cassandra with one quorum level. Okay, the beauty of the Cassandra is it is not strictly AP system. We can configure Cassandra as CP system, as AP system, as CA system also, because Cassandra has 3 quorum levels. It supports 3 quorum levels. First one is 1. Second one is name itself has a quorum. It should satisfy the n by 2 plus 1 servers like MySQL. Third one is all. Okay, this one, if you configured one as a quorum level, it will be behaves as AP. If you configured as quorum as a quorum level, it will be acts as CP, which already we discussed in the MySQL case. If we configure all, it will be acts as CS systems. Okay, let's discuss about this one. Okay, simple. Like MySQL, we have 2 networks. Network 1, network 2. Okay, and in the similar way we distributed our replicas. 2 replicas in the network 1, 1 replica in the network 2. Okay, that means this is replica 1, this is replica 2, this is replica 3. Okay, we placed. Let's configure quorum is 1. Quorum is 1. That means even one server or replication factor is equal to 1, okay, should able to gives read and write response. Okay, even one server is available, it should able to give read and write responses. In the similar like MySQL, every node accepts write request and also the read requests. Okay, this is what the behavior of the Cassandra with quorum level 1. Okay, let's discuss why it is a AP system with quorum level 1. Let us consider network 1 is down. Network 1 is down. What happened if the network 1 is down? All read and write requests goes to network 2. Okay, quorum level satisfied. Okay, read and write operations works fine. Okay, which is absolutely good. After some time, after some time, network 1 is up. What happened? Data transfer happening between network 1, network 2 to network 1. Okay, during the data transfer, if request comes to network 1, there is a chance it should gives wrong data. Okay, there is a chance it should gives a wrong data. Now what is here compromised? Okay, see here, if the network 1 is completely down, all the requests will comes to the network 2, all the reads and writes. After some time, if network 1 is up, network 2 is start transferring the data, starts transferring the data. During the data transfer, if any read request will comes to the network 1, there is a chance it will be gives as wrong data, because still data transfer is happening, it is not yet completed, so that it does not gives the recent write. There is a chance, because it is eventually consistent, data transfer is still happening, quorum level is satisfied, so definitely it gives a response, because the quorum level is 1 here. That is the difference. The quorum level is 1. Okay, definitely the network 1 would gives a response, but there is a chance it may be a wrong response, because the data transferring is still happening. Data transfer is still happening. So it should gives a wrong data. Now what will happen? What is compromised here? Consistency is compromised. Okay, consistency is compromised. Let's assume that network 2 is down. What happened? Network 2 is down. network 2 is down. What happened? All writes and reads, okay, all writes and reads coming to network 2. Okay, that means there is a single server, quorum is satisfied, okay, all reads and writes are working. Again, after some time, network 2 is up. Okay, network 2 is up. Now what will happen? Data transfer is happening from network 1 to network 2. During the data transfer, if requests comes to network 2, there is a chance it gives wrong data, because quorum is satisfied. What is compromised here? In this case also, consistency is compromised. Okay, that's why the Cassandra with quorum level 1 is always, we will state as a AP system. Here consistency is compromised. In this case, we already discussed with n by 2 level plus 1 with quorum level. What is compromised here? Availability is compromised, right? If the network 1 is completely down, if all the request will goes to the network 2, what will happen? Quorum level is not satisfied. Definitely reads and writes will not work. Entire cluster is going to be down. Here availability is compromised. All means what happened? All the servers should alive. Even one of the network will goes down, entire application is crashed. That means here partition tolerance is compromised. All itself indicates that it should have the quorum level of all the 3. Okay, if even the network 1 is down, it doesn't works. Even the network 2 is down, it doesn't works. It is not survive at all. So that's why Cassandra has a 3 quorum levels. We can tunable based upon your requirement. Generally, it is not preferred in production at all. Based upon the requirement, you can tunable as AP, you can tunable as a CP. Okay, but in this case, let's don't get confused here. But MySQL, even during the data transfer, if the request will comes to the network 2, what will be happen? There is no compromise in the consistency, because 2 servers is a quorum level. Out of the 3, the MySQL checks the response from all the servers. Out of the majority, it will be take from the 2 servers. That response will be the given back. So that's why the consistency is there here. But in the Cassandra, what will happen? The quorum level is 1. During the data transfer between the either from one network to another network, if the request will comes to that network, what will happen? The quorum level is 1. There is a chances of giving the wrong data. It doesn't checks for the other server's response. Okay, so that's why here consistency is compromised. That is a major difference between with quorum level n by 2 plus 1 with the quorum level 1. Okay, there is one use case again. MySQL, because we will see this Cassandra and MySQL Cluster Mode is peer-to-peer communication. That means every node should accept the writes and reads. Now we will check MySQL with Master-Slave mode. Let's see what is compromised here, whether it will be the CP or AP. Let's check. Okay, again we have 3 nodes. We have network 1, we have network 2, okay, we have network 1 and network 2. Let's see. Here network 1, it consists of 2 nodes. Here network 2 consists of single node. Okay. Here, what are the rules? Let's assume that this is a master. This is not replicas. Okay, this is a master. This is a slave, because it is a master slave architecture, not a cluster mode architecture. That is a difference. Okay, master slave. Generally, here master slave accepts writes. Okay, slave nodes accepts reads. Reads only. Here writes and reads. Okay, master slave accepts reads only. Okay, third rule is if master goes down, another slave would becomes master. Okay, another slave which is in sync, which is in more sync, it becomes a master. How it works? Okay, for example, let's understand very clearly here. If the request will comes to the master, this is what write request. Okay, the master will replicate that writes to the slaves asynchronously. Okay, how it works? Replication happens asynchronously. Okay, replication happens asynchronously. Let's assume master goes down. What happened? Okay, master goes down. What happened? Let's see. This is goes down. This is completely down. What happened? Out of these 2 nodes, which is having a more sync with the master, this becomes a master. It becomes master. Let's assume this server has a more sync. Okay, this becomes a master. For now, writes will be goes to this master. Write will be goes to this master, and this is asynchronously sync with the slave. What happened? Majority sync node will become master. Okay, will becomes master. Second case, if this server is again up, what happened? If server again is up, the server is again up, now it is up. What will happen? Automatically again data will be transferred from master to slave. Okay, data will be transferred to the master to slave. Data transfer happens. Okay, if read comes to up master which is up, okay, during the data transfer, what happened? Consistency is compromised. Consistency is compromised. Simple. Right? There is a chances, right? For example, there is a master and two slaves. One of the masters gets down. This slave would becomes master. Later, this master is going to the up. What will be happen? The data transfer will be start from master to slave. Master to slave. What will be happen during the transfer? If the read request is comes to, what will be happen during the up? This master becomes again slave, right? When it is going to be up, this becomes a slave. Once the read request which comes to the slave, now read request which comes to the slave, what happened? During the data transfer, there is a chances of data inconsistency. That means consistency is compromised. Again, during the replication process also, okay, this is a master. Okay, this is a master. When the write will comes here, it is asynchronously replicates, right? During the asynchronously replication which is still happening, if the immediate read will be happened, there is also chances of inconsistency. Okay, even during asynchronously replication happening, if there is an immediate read, there is a chance of chances of inconsistency. That means consistency is compromised. Okay, Let's assume there is a master and slave here. Let's assume this is master, this is okay. Master slave will be happen. Let's remove. Okay, let's see. Master, there are two slaves. If network 1 is completely down, what will happen? This slave only becomes a master. That means this master will becomes an act as master. This node only acts as a slave. Okay. If the network 2 is completely down, what will happen? For example, this is a master. If network 2 is completely down, what will happen? Within the two nodes, one of the node becomes a master. Okay, during the network fall downs. Okay, if the network 1 is completely down, this slave will becomes a master. There is no slaves at all. This only accepts the reads and writes. Okay, if the network 2 is down, what will happen? This is a master here. If the network 2 is down, out of this master then it becomes a slaves, right? After the network 1 is up, this in this slaves, one of the slave becomes a master. There is no problem in the network downs in the master slave architecture. But by default, when the data transferring is happen, even the network is up, during the asynchronous replication is happening, there is a chances of data inconsistency. So that's why strictly MySQL with master slave architecture should be used for the AP cases. In this case, the consistency is compromised. Okay. Now, the most interesting architecture and most important asked in the interview questions is Elasticsearch. The beauty of an Elasticsearch is mixed one. Mixed use cases. We need to understand very, very clearly here. Okay. See here. Network 1, network 2. It is a mixed of both the two architectures, peer-to-peer architecture like cluster mode and also the master slave architecture also. It is a mixture of both the architectures. Okay, it is a mixture of both architecture. That means peer-to-peer plus master slave. Okay, see, let's see here. There is network 1 and network 2. We have two nodes, two replicas. In network 1 there are two replicas. In network 2 there is a one replica. Okay, see here. Here, how the Elasticsearch would works, we need to understand. The first one is for electing the master, it follows quorum level. That means that is n by 2 plus 1 for electing the master. For data transfer it follows master-slave architecture. Okay, this is the beauty of an Elasticsearch. For data transfer, it is follow the master-slave architecture. For electing the master, it follows a quorum level. Okay, for example, if you take 3-node cluster, 3 nodes, 2 nodes in one network, in network 1, and 1 node in network 2. Okay, here the beauty. First, for electing the master, and another point I would like to add is only master node accepts, reads and writes. Slave nodes only accepts, reads. Okay, let's see here. This is 2 nodes. These are not replicas, right? Like Cassandra and MySQL Cluster Mode. Just these are only the nodes. So for electing the master, see, let's see, network 1 is down. Let's understand here. Network 1 is down. For better understanding, I will draw again here. Okay, these are network 1 nodes. This is network 2. Okay, for example, network 1 is down. What happened? We have 3 nodes. For electing the master, it should maintain the quorum level. Okay, that is n by 2 plus 1. If network 1 is completely down, this is down completely. This is completely down. Okay, only this is an up. Okay, what happened? How many nodes are there? We have 1 node. We have 1 node and there is no master. There is no master at all. That means writes will not happen. Writes will not happen. What is a compromise here? Availability is compromised. Will the reads will be happen? Yes, this is a 1 node which is available. Reads will be happen from this. Okay, only reads happen. Okay, availability. After some time, what happened? After some time, network 1 is up. Okay, network 1 is up. we have master from network 1, because what happened, we have master from network 1 because quorum level is satisfied. Now reads and writes happen. Reads and writes happen. Right? Now see. Happened perfectly. There is no issue at all. Let's assume network 2 is down. Okay, we have 2 nodes. Two nodes in network 1 and 1 node in the network 2. Okay, now what happened? This is up now. This is completely down. Okay, this is up now, this is completely down. What will happen? Master is up, master is there because quorum is satisfied. Reads and writes, happen. Okay, happen. Let's, if network 2 is up, what happened? It when network 2 is up, after some time, okay, data transfer is starting. Data transfer is happening from where? Network 1 to network 2. Okay, so that means network 1 master to network 2 slave. During the transfer, if request comes to network 2 slave, what happened? There is a chance of giving wrong data. What is compromised here? Consistency is compromised. Consistency is compromised during the data transfer. This is how the Elasticsearch will work. This is how the CAP theorem. Okay, for the Elasticsearch, the beauty is it follows both the architectures, n by 2 plus 1 and also master slave. So that's why in one case, based on the cluster arrangement, in one case availability is compromised, in one case consistency is compromised. Okay, I hope there is no confusion in the Elasticsearch architecture. I hope you people clearly understand what is a CAP theorem and what is meant by the consistency and what is meant by the availability, what is meant by the partition tolerance, in which cases we prefer the CP, in which cases we prefer the AP, in which cases we prefer the CA, and also we understand clearly MySQL Cluster Mode architecture and also the MySQL Master-Slave Architecture and Cassandra architecture and Elasticsearch architecture, and we understand in depth what the CAP theorem will states and why all the three power properties will not satisfied at once in this video. Okay, so that's it for guys. This is about the CAP theorem. It is really very important for the interviews. If you like this video, please like, share and subscribe. Thank you.